Hey everyone, how are you? Welcome to my talk. My topic today will be improving developer experience with hot module replacement and Webpack. And as I actually call it, NativeScript on fire. So to kick off, I have a question for you. How many of you are NativeScript developers? That's good, that's good. And for the rest of you who are not, I can tell you that now is the perfect moment to start using NativeScript. Because we have a major release coming up in a few weeks, and it's going to be huge. I and the whole team, we think that this is the biggest release yet, and it's going to improve the development experience dramatically. So start using NativeScript. Cool. My name is Stanimira. I'm from Bulgaria, and I'm a developer. I work on NativeScript. And there I'm working on the Angular integration, code sharing, the NativeScript schematics, and a lot of Webpack stuff. Because Webpack is actually the backbone of all our performance optimizations and the code sharing story. And of course, the hot module replacement feature that I'm going to be talking about today. And I really love Webpack. I mean, as you can see in that photo, this is me, as you can see. I'm smiling, and this here is a Webpack error. But I'm not scared anymore, as I used to be. How many of you are not using Webpack? Hey. Okay, not too many, but I'm jealous. I hope you never have to use it. Okay. All right, so as I said, I'm from Bulgaria, so the whole trip to come here took me about 16 hours. It was a great trip. I must say that I came up with a lot of bad ideas, especially for this talk, and I decided to turn one of them into reality. So this is going to be a pretty strange talk, because it's going to be like a play. And obviously, I don't have actors, so it will be pretty much a monologue. I don't see people leaving. You should be. So the first act, the scene enters a NativeScript developer, like many of you here. And he says that NativeScript is great, as we all know, because it works both on Android and iOS. You can choose from all the popular web frameworks out there, Vue.js, Angular, or you can use just plain JavaScript. And the really cool part is that you can share your code between web and mobile if you're using Vue.js or Angular. That's cool, right? But the NativeScript developer says to us that the development experience with NativeScript sometimes is not what we expect. Why is that? I'm just going to show you. I mean, let's see this video. So what we have here, we have a NativeScript app with a login form. We log in. This obviously takes a while, because we have to type stuff. We make mistakes. But eventually, we sign in. And we go to something like an admin panel. And here, I want to make some change while I'm developing it. I want to change that text here to be different. And change it. I save the file. And what happens? The app restarts. I'm back on the first page, and I have to log in again. I eventually will log in. I'm completely out of my flow by now. And I see the change. And that's cool. And hopefully, I made the right change, because I have to repeat that many, many times. I'm not going to start it over, because it's terrible. So what is the reward cycle when we are developing a NativeScript application? We make a change. Then the application restarts. We have to manipulate the application back to its old state. In our example, we had to log in again. We had to navigate to the page where we were. We eventually see our changes applied. And then we repeat that many times. And that's horrible. So we got to do something to fix it. First, let's ask us a few questions. What if we didn't restart the app? I mean, we made a single change, right? What if we replaced only that changed module? And what if we reloaded only the current page that we are in, instead of rebooting everything? let's see how that would have looked like. We are logging in again in that perfect scenario. We have the same page. We're going to make a change. Again, we're saving the file, and we see just change. We're making another change, and again, we see that change. So that looks better, doesn't it? It's kind of faster. You can actually see what you did after 1 or 2 seconds. This is hot module replacement. But I won't stop here. So it's really important to note that HMR is hot module replacement. I will repeat it again. It's replacement. It is not reload. Please don't call it reload. I don't know who started that, but it's hot module replacement. OK. You should use it because it's awesome. But before using it, you need to upgrade your apps to NativeScript 5. And here's the tricky moment that NativeScript 5 is not released yet. It will be in a few weeks, but we do have a release candidate. So if you go on that link later on when you have the slides, you'll see how you can upgrade your apps to NativeScript 5. Then you should build your app by providing that flag, --HMR. And you have hot module replacement. And there is another option, and that is to use the TNS Preview command. And that's another feature that's coming in NativeScript 5. And because it's pretty cool, I'm going to talk about it a bit. First, what do you get from TNS Preview? You don't need Android and iOS setup to use it. You just need to have Node, npm, the NativeScript CLI installed, some mobile device as well, and then you can automatically start using NativeScript right on the spot. You don't need to install the Android SDKs, Android Studio, then create an emulator, then cry because of that doesn't work so well, especially if you're trying to use Android, not to say anything. Also, the TNS Preview is really, really fast. You gotta try it for yourself, and you'll see. It's just amazing. And here's something that I realized you can do. Actually, if you have an iPhone and a laptop that is not a MacBook, you can use the TNS Preview and build iOS applications and sync them to your iPhone. So you don't need a MacBook. That's a big thing. You can actually use a Linux machine to build for iOS. You can also use Windows, but who does that? Anyway. All right, let's see the same video, but we're starting over. I'm just going to show you the whole deal. We are running TNS Preview --HMR. Probably you can't see it, but you can trust me. And what happens here? We get that barcode. Then from our mobile phone, we gotta scan the barcode. And we're scanning it. Then the app is being built on our machine, and then it is synced on the phone. And here it is. We don't need any other connection. And that's the video that we saw previously. We're logging in, and we have hot module replacement enabled. OK, I'm going to pause it here. Let's see it again. I mean, it's pretty cool. We're changing the text. We see the change instantly. We don't have to restart the app. We don't need any setup. Pretty cool. All right, it's time for the second act. We learned a lot so far. That NativeScript is great, and it's becoming even better. But let's see something else. How do we build an application? I'm really getting into some details right now. You don't need to know them, but it's always good to know how things work under the hood, right? And I must say that this scene is pretty inaccurate because it simplifies a lot of the details, a lot of the things that Webpack does, but you'll get the idea, right? So the scene enters Webpack, and Webpack says every JavaScript file is a module. You can think of a module just as a single unit. You don't have to know anything more than that. Also, every HTML file is a module for a Webpack. Every CSS file is a module. And if you see where I'm heading, pretty much everything is a module for a Webpack, except for what's not. And all the modules should be bundled together. They will be bundled together in a single file. Again, that's not true in most of the cases, but let's say that we have just that JavaScript object, the modules map. And the keys are the paths to our files, the files in our project. The values are functions that wrap the actual code. So here will be the code of app.js. And of course, it may not be the actual code because the Webpack build process may change it a lot. For example, if we had a TypeScript file, the Webpack build process will transform that into JavaScript and then convert it to a module. What happens if we have another file which imports app.js? Obviously, we no longer have the app.js file in the file system, right? Everything is in that single object. Well, we're going to replace that, or Webpack is going to replace that with modules map app.js. So we're going to receive the code that is here. All right. The second part, how does Webpack do module replacement? So here we have a few other actors, the hot module replacement plugin, Webpack, and our favorite NativeScript developer. First, we make a change to a file in our project. Then the hot module replacement takes that file, executes the Webpack build process, but just for that single file, and produces a module just for that file. Then Webpack replaces the changed modules. It replaces them in the object that we saw. So if you make a change to app.js, Webpack will go ahead and replace the code. And the other file, which was pointing to app.js, now will point to the new code. That's it. It's pretty simple. So what we did so far, we didn't restart the app. We only replaced what we changed. And what is left is to apply the changes to the application so we can see what changed. Scene 3, applying the changes. Cool. So we have the Webpack and a NativeScript developer. What Webpack says is that every module that is changed should have an update handler inside our application. Or it won't even replace it. It will just ignore the change. And we as developers say, yeah, sure, we get that, but we don't really know how to do it. But Webpack has a great documentation, and it's going to show us now. So the first way to do it is by writing a self-accept. So in the module that we are changing, we are going to accept the change. So we need to add that single line. That's module hot accept. It can take some arguments, but they are not important right now. And what is important that the module will be reevaluated. But all its parents, or the other modules which import the changed module, won't be executed again. How does that look? So we have 3 files here, full, bar, and bus. Bar imports full, and bus imports bar. So we make a change in full.js, and Webpack starts looking for an update handler. It first asks full.js itself, do you have an update handler for yourself? And because full.js accepts itself, Webpack is OK with that, and it will reevaluate it. What happens with the rest of the modules? They're pointing to the new code, but they won't be executed again. So that can cause certain problems, right? That's why we have different way of accepting changes. And that's a parent accept. So in some parent module, we're going to write module hot accept, provides the name of the dependency or an array of dependencies that we want to accept. And also the second argument, we can provide a callback that will be executed whenever the module is replaced. What's important, the whole dependency chain is reevaluated. We're going to see that. And the callback is executed. Again, let's say that we are going to make a change in Full.js again, but there is an accept handler in Bash.js. So what Webpack will do, it will start looking for an update handler. We don't have an update handler in Full.js. So we're going to ask the module bar.js, which imports the first one, do you have an update handler for that change? And we don't have it. So next up, we're going to ask the third module, do you have an update handler for, here's the tricky part, we're not asking for Full.js, but we're asking for the direct dependency. Do you have an update handler for bar.js? And here we have that code. We are accepting all changes for that dependency, and we want to execute some update handler. So Webpack is OK with that, and it starts executing the code. It executes Full.js, the change module. Then it executes bar.js, and now bar.js points to the new Full.js, and all the changes there will apply. Then it stops. It won't execute the final module, bar.js, but it will execute the update handler. That's it. I see that you're not too excited about that. I wasn't either. So that's why we decided to simplify that a bit. And that's where NativeScript comes in. And actually, don't worry, you don't have to write that code. NativeScript will do that for you. So forget about the last 10 minutes. It's OK. I had to talk about something. So what's next? NativeScript will actually do that for us. We don't have to know about it. But there is another thing that's called Angular. And Angular is not simple. I'm saying that with a lot of pain, but it's true. OK, let's see how hot module replacement works with Angular. We have the same app, but it's a NativeScript Angular app. So we go ahead and make a change. That's our home page, actually. We haven't made any navigations, nothing. We will go ahead and change the text in the action bar. So we change that, and it should be applied here. So we save the file, and nothing happens. So we make another change. Hopefully it will apply. Nope. All right. At this point, we're kind of pissed off already. And still, nope, it doesn't work. Why? We must missed something. Well, about 5 slides earlier or something, we saw that. And yeah, we missed that text there. Yeah. You don't see it probably. OK, I'm going to zoom it. So NativeScript will handle everything, but not if you're using Angular. Because Angular is complicated. But it's OK. I'm going to show you how to enable hot module replacement there. That's what our third act is for. It's for making Angular work. The first part, we should accept the changes. So here's what we need. We need that code snippet that you have to go ahead and just copy in your application. And you don't have to understand how it works, because it's weird. And hopefully, at some point in the future, you won't have to do that. But we will see when. All right, I'm going to explain it. What we have here, if the module is hot, that means if hot module replacement is enabled, we're going to do something. If it is not enabled, Webpack, when we build for production, this thing will evaluate to false, and the code won't be included in our production build, which is good because we don't need it. Then we're importing a function from NativeScript Webpack plugin, and then we provide some update handlers. That's a module type factory. And what is its job? It should return the app module. The idea is that we are accepting all changes here that are coming from our root Angular module. And because the root module is re-evaluated, its code is new, we need to have a function which returns the new module. All right. Also, we have something called a wifesync callback, which should trigger the hot module update. And the most important thing, as I said, we are accepting all changes to app module. And app module is the root module, so it actually depends on everything else, or everything else is imported eventually in the app module, kind of. Now that I think about that, probably it won't work with lazy loading, but I haven't said that. All right, and the final thing, if I try to hide that, is that we are bootstrapping our app and we're providing these options. So that's it. You don't have to understand the code. You just have to put it inside your application. OK, let's see if it works now. Hopefully it will. This is my app. Oh, I have a notification. I have some conference to go to. This is the app. It's already running. I'm not going to run the build again, although it's pretty fast. I'm going to go ahead and change the home component again. Do you see everything? Maybe a little bit. OK. I'm changing that button, and it's working. Awesome. What about if I go to the About page and then go ahead and change something there? I'm going to change the text, if I find it. All right, this application is awesome. So are you. Cool. We're changing, and what happens? Yeah, the app didn't restart, but we're back to the first page, right? If I go here, I can see that the change is applied. But all right, let's change again. That should be working, right? Nope, it's not working. All right, so what happened? We didn't persist the route. What happens is that the Anchor application is bootstrapped anew, and it automatically goes back to its default route. And that's kind of normal. So we gotta fix that. How do we keep that route? It's pretty simple. We can keep it anywhere, virtually. We should save it before the reload starts, and then we should get it back after the reload finishes. How do we do that? We have two wifesync events, on before wifesync and on after wifesync. Here's how it should look like. We have some random variable called cached route. We subscribe to before wifesync, and we receive the module reference. That is our root Angular module. And we're using that to get an instance of the router. And from that router, we can get the current URL. Pretty simple, right? We are storing then the URL in the cached route variable. After the wifesync finishes, again, we have the module reference of the newly bootstrapped Angular app. Then we can get the router again, and then we can just navigate to the old route. That's pretty much it. Let's see how it looks like. Cool. I'm going to go ahead to the main file. And what's important here that I'm making changes that should persist the state in some way. So they won't be reloaded automatically. So I have to rebuild the app, unfortunately. I have a module called persist state. I assure that it contains the same code that we saw, but it has a few more checks, like have you actually navigated? What happens if the navigation fails? Obviously, we should go back to the default route then. All right, so I'm going to the About page. And again, I'm going to change something. Come on. OK, it works. It's kind of fast. This is cool. But what happens if I go back? That wasn't that cool. And It's pretty simple. We actually bootstrapped the new Angular application. Then we directly navigated to the final page. So we don't have history. If we press the back button, we will close the app. So there are some ways to fix that. For example, we can get all the navigations that we made, and we can repeat them after the reload starts. But I'm sure that you can implement that yourself, because I'm not going to do it now. Sorry. OK, here's the app again. What happens if we log in? I'm signing in. Then I want to go to the admin page. And I want to make that size a bit smaller. What will happen? OK, I couldn't navigate. That's sad. So what happened is that my user is gone. So I walked in, but again, the app restarted. I tried to navigate to the admin panel, but I don't have permissions to view it if I'm not logged in. So again, I have to make all the navigations. I have to log in to see the actual change. But there's a way to fix that as well. How shall we keep the state? And I'm not talking just about user sessions and stuff. You can store quite a lot of things in your app. So they will be all gone if you restart the app. But we can keep them. The idea is simple. We can keep the state anywhere. We have to save it before the reload starts. That looks familiar. Yeah, it's the same thing. It's the same thing as the routing. And actually, now we need a state management. And there are some plugins that are out there in the ecosystem that we can use, especially for Angular. So we're starting to ask ourselves, should I use Redux? Or should I use NGRX? Or should I use NGXS? Or anything from the other 10 state management systems? The truth is that it doesn't really matter. And I chose to use something called Akita. Have you heard about Akita? No? Awesome. So you're going to learn something new today, at least. The cool thing about Akita is that, first, it's platform agnostic. It works with Angular, without Angular, with other frameworks out there. And the coolest thing is that it has this logo. I mean, I couldn't choose something else. When I see that logo, here's what I think of. I mean, it's so cute. But seriously, Akita is pretty awesome. It's really gaining a lot of popularity lately, and you should give it a try. It's very easy to set it up. OK, the idea about Akita. We have some user that walks in. We're going to store the user in a session, obviously. We need a session query. It's like the getter for our session. We can call getSnapshot and get the logged in user. We also need a session store. That's the setter for our session. We call updates to the store, and we store there the logged in user. And after that, we can use these two to keep the state, right? Before the live sync starts, we're using the session query. We are getting the user. And after the live sync finishes, we're using the session store, and we're updating it with the cached user. Is everything clear here? If you have any questions, it's OK to interrupt me. I don't mind. OK, cool. Let's see that. Let's see that. Yeah.
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 With the routing and the state saving, are both of those things specific to Angular, or to what extent are those also necessary for doing pure NativeScript content?
You don't need them for pure NativeScript. For the state, you can do it in pure NativeScript. You're not going to lose the state always, but you're going to lose the page state because we're reloading only the current page.
I see.
Yeah, so you can keep the current page state and then reapply it.
OK, thanks.
You're welcome. Thanks for the question. All right, so let's see how Akita works. I'm just going to go ahead, stop the application, and in my magical persist state file, I'm going to uncomment some code, the code that we saw. Let's remove that. Rebuild the app. And what we're looking for is when we log in and made a change to the admin component, the change should be applied and we should be on the same page. That's the most important thing. Yep, cool. We log in again. We are logged in. We go ahead and we are changing some stuff here. I won't break it. Yay, it's smaller. Now if I change it, it will be bigger. All right, that's the shiny demo. And the coolest thing is that we managed to save the state. Again, you don't have to use Akita. You can use whatever state management plugin, or you don't have to use state management plugin at all. You just have to subscribe to 2 events, and that's it. All right. I'm coming to an end. That's the final thing, but it's not really. Why not? So the hot module replacement will be available in NativeScript 5, but it's still kind of experimental. Here are the things that we have so far. I really can't demo anything else, I think. There are a lot of things that we can do, because hot module replacement gives us tons of possibilities. And we have a whole list of features, maybe 20 of them, just related to hot module replacement. You gotta help us choose, or if you want to, you can start working on some of them, and we can help with some guidance or whatever. So here are 2 links that you probably won't need right now, but after you have the slides, you can go ahead and check out the design document for the feature to understand how it works in depth. And this will give you enough knowledge to actually start working on some problems. And we also have a tracking issue in GitHub about hot module replacement. You can see what's left there, what is not working, and you can vote for the best options. Cool. I think, do we have time for questions? I don't have a, yeah, we have. OK, if you have any questions, yeah, I'll go back. Where? Oh, yeah, sure. All right, and if you have any other questions, yeah?
I'm using the TNS debug now instead of slide sync, and that usually works great. It might take a few seconds to reload that, which is really fun. But I noticed that if it errors out, I do have to kind of close the emulator and restart it again, which is, no big deal, just a minute. Would hot module replacement, would it replace live sync, or is it a better live sync? And also, if it errors out, would it crash?
All right. So if you run TNS Run or TNS Preview with hot module replacement, and you make some mistake in your app, and the app crashes, the app will crash, obviously. If you restore that, if you fix the bug, the app will be restarted. All right, so you won't have to do anything manually. You don't have to close it. It will restart. Another thing, if you make a change and the hot module replacement doesn't work, if you don't accept the change anywhere, if something happens, again, the app will be restarted automatically. All right. Yep.
Do you use this for the cloud build?
No, it doesn't work yet. You can vote for that feature. I think it's not logged in, but yeah, we gotta think about that. You're welcome.
What about Vue.js?
Oh yeah, that's my favorite part. I'm sorry I missed it. So Vue.js just works with hot module replacement. Yeah. Cool. Any other questions?
The preview.
Yeah.
Is that a full view? Is it global?
It's a great question. So we don't do the full native build. That's why I don't need Java or Android or whatever. We actually built only the JavaScript files. Only the JavaScript files, and then we sync them on your phone. So most of the times, if you're not installing plugins that depend on native plugins, or if you're not extending any native classes, that's 90% of the NativeScript development, it will work. But if you need a custom plugin, which depends on something that's an Android or an iOS library, the preview won't work. That's a limitation.
The base class is already compiled in the NativeScript default, right?
Exactly.
We can render on the default. We don't need to do it.
Exactly.
Yeah.
The app is already built on your phone, and you just replace the assets. It's a great question, thank you. All right, someone else? I'm actually here during the conference, so you can find me and ask me. Or you can follow me on Twitter, please. Thank you.